Hello everyone, I am Professor Anis Vora and I welcome you all in this video lecture. In this video lecture, we will study about the working and VI characteristic of the SCR. Before we start VI characteristic of the SCR, we know the different operating mode of the SCR. We have forward blocking mode, that is the off state of the SCR. We have forward conduction mode, that is on state of the SCR, and we have reverse blocking mode, and that is also off state. And based on these three operating mode, we will study the VI characteristic of the SCR. VI characteristic can be defined as a relationship between applied voltage and current passing through, and that is known as a VI characteristic. Now let us see the VI characteristic of the SCR. We have forward voltage as well as reverse voltage on the x-axis. On the y-axis we have forward current as well as a reverse current, and that is anode current. So when we apply forward biased voltage between anode and cathode and gate is kept at 0 voltage or open, so only the leakage current flows between anode and cathode, because junction J1 and J3 both are forward biased, but junction J2 is in a reversed bias, and the depletion region across junction J2 have increased, and that will block the conduction of the current, and that region is known as the forward blocking region. When we apply a forward biased voltage to the gate, meaning is with the intermediate P layer we are applying externally the gate current. At that time junction J2 becomes forward biased and conduction of the current through anode to cathode will flow, and that is the on state of the SCR, and it is known as a forward conduction region. High value of current flow between anode to cathode after junction J2 becomes forward biased, and the series connected load only control the value of the anode to cathode current. When we apply voltage in a reverse biased mode between anode and cathode, that is anode is negative and cathode is positive. In this condition junction J1 and junction J3 both are in a reversed bias. Gate is at 0 voltage or not applied at all, and only a leakage current flow, and this mode is known as a reverse blocking mode. As we go on increasing the reverse biased voltage across anode and cathode at certain value of voltage, that is known as a breakdown voltage, junctions break down and very high current start flowing through the SCR. Now let us understand the working of the SCR. To understand the working of the SCR, two transistor analogy is very helpful. As we know the construction of the SCR, that is a PN, we have 4 layers, and if we divide the intermediate 2 layers, then we can observe that we have 2 transistors. One is PNP transistor and one is NPN transistor. So if we understand with the help of two transistor analogy, it can be reconstructed as the upper transistor, that is PNP transistor, and the bottom one is another transistor, and that is the NPN transistor, T1 as well as T2. We can see that base of the first transistor is connected to the collector of the second transistor, and in the same way base of the second transistor is connected to the collector of the first transistor. Anode and cathode is connected, and with the intermediate P layer, gate is connected. So this is known as a two transistor analogy, and the working of SCR with the help of this two transistor analogy can be understood very easily. So again, we have two transistors, one is PNP and one is NPN. So first transistor T1, that is a PNP transistor, and second transistor, that is T2, that is a NPN transistor. Now as per the figure, we can see that base of the second transistor is connected with the collector of the first transistor. In same way, base of the first transistor is connected with the collector of the second transistor. Emitter of the first transistor work as an anode, and it is given positive supply. Emitter of the second transistor work as a cathode, and that is connected with the load to the negative supply. Now to understand the working, we know that as long as gate is kept at zero level, and if we apply forward biased voltage between anode and cathode, there is no any conduction of the current. But as soon as we apply gate current Ig, now let us see what happened. When we apply gate current, meaning is it is connected to the base of the transistor T2. So base current Ib2 flows for the transistor T2. Transistor T2, when base current is applied, it change its states from off state to on state, and collector current for the transistor T2 start passing through. As collector current pass through the transistor T2, which is connected to the base of the transistor T1, meaning is the base current for the T1 also flows. If the base current to the transistor 1 is applied, meaning is collector current of the transistor T1 also start flowing. That is IC1. Now IC1 collector current is connected to the base of the transistor T2. So base current of the transistor T2 increase with the collector current of the transistor T1. We know that as base current goes on increasing, the collector current for the transistor T2 also increase. And if collector current of the transistor T2 increase, the base current for the transistor T1 also increase. And this is a very cumulative effect, and it goes on increasing based on the gain of the transistor T1, that is alpha, and gain of the transistor T2, that is beta. At certain stage, even if we remove the gate current, then the flow of current from anode to cathode sustain. So with the help of this two transistor analogy, we can understand the operation of the SCR. Now let us see the application of the SCR. We can use SCR as a speed control in DC motor, as a temperature control in furnace. We can use SCR in resistance welding, as well as we can use SCR in electronics ignition in automobile, as a rectifier and inverter. In chopper also we can use SCR. So we have multiple application of SCR. Thank you for watching my video. Keep watching. Thank you very much.